way to compare two or more amounts. Thanks. So for example, in our warm-up today, it was for every 3 stars. What else was happening with those 3 stars? 5 circles. So our ratio was 3 to 5, and it's at TO25. We're comparing 3, the quantity 3, and we're comparing that to 5. There's 3 different ways we can write a ratio. Does anyone remember one of the ways we can write a ratio? The 2 dots, the colon, 3, 2, 5. If we're going to read a word problem or we're going to write a word problem, this is how normally we would see it in the real world. Even if that's the way we see it in the real world, mathematically, when we turn it into a problem, we like to switch it into a fraction, 3 to 5. We still say 3 to 5, but when we deal with calculations, this is how we would write it. What's another way we can write a ratio? Does anyone remember that third way? The slash is the same thing as a fraction. Same idea.
What word might you use?
3, 2, 5. Actually spelling out that word T-O.
Can I borrow Mr. Abib?
Mm-hmm. Alright, so that's our ratio. Generally speaking, like I said, in math, we're going to use this one the most. You might see this one a lot, but when we write it, we are going to write it in that fraction form. And then this is how we say it. We say 3 to 5. Okay? So a lot of times we'll see this 3 colon 5. When we show it in our work, we'll write 3 over 5. And then we'll say 3 to 5. Wasn't that a really good thing that I just came up with? Dang. All right. It's really not that cool, guys. All right. Next up we have proportion. So when you hear that word proportion, and you want to keep something proportional or proportionate, what does it mean to be proportional or to be proportionate? Or what's something that you would want to be proportional? Yeah, like a specific amount, right? Yeah. So like when you're making Kool-Aid, you want the amount of water. The more water you put in, the more what do you need to put in? Kool-Aid, or the more sugar you need to put in. If you just add a gallon of water to a normal Kool-Aid, how's that going to taste? It's just going to taste like water, right? You guys have all had that, like, right, the lemonade that, like, you see it's, like, yellow lemonade, and you're like, oh, this is going to be great, and then you drink it, and you're like, it's water. Or the other way around, you get too much lemonade in it. What does that taste like if you have more lemonade in it than water? Sour, yeah. Another thing you might want proportional is like your clothes. Okay, when you buy a sweatshirt, depending on the style of sweatshirt, do you want the length of your torso, the length of your body part of the sweatshirt, to be proportional to the length of the arms? Yeah. Should someone my height have the same arm length as Shukri? No. Let's see. Shukri, let's compare it. Would that make sense for us to have the same arm length? No. Ours are way different. So a sweatshirt that fits Shukri should probably be taller, it should be longer, but then his sleeve should also be longer. A sweatshirt that fits me is going to be narrower, not narrower, shorter. And then the sleeves will also be shorter. So we want that to be in proportion. So proportion in math, how did I get all wet?
I don't know, I think we're drinking.
Oh. Okay, means equal ratios. Thanks for always letting me pick on you, Shukri. I just know out of everyone, like, you're guaranteed to for sure be taller than me. So it's just fun to pick on you sometimes. Everyone is guaranteed to be taller than me, but not as dramatically. Not in the same proportion as you are to me.
You're really short.
I am really short. All right, equal ratios. So, for example, when we did our grouping earlier with Sarah and Destiny, it was for every 3 stars, there was 5 circles. But we kept that proportional. When Sarah all of a sudden drew 15 stars, how many circles did Destiny draw? 25. Are those the same fraction? They don't necessarily look the same, but could we make them the same? Could we simplify the fraction?
Yes.
Yeah, what can we divide 15 and 25 by?
I don't know.
Shukri doesn't know. Does somebody else know? Who? Hold on. 5. If you do 15 divided by 5, we get 3. 25 divided by 5, we get 5. So it's proportional. Every time Sarah drew some stars, Destiny also drew some circles in the same amount every time. All right, so we have 4 examples that we're going to go through. There's kind of 3 big types of problems we're going to be doing today. But we're really going to be doing these problems all throughout Chapter 7. Okay? So this is just the starting point. This is a review of things that we did algebra. And then we're going to continuously do this throughout Chapter 7. Okay, our first thing that we're going to ask ourselves is it a proportion? So we're going to be given 2 ratios, and we want to know, do those ratios create a proportion? So for our first one, we have 3, and I'm going to use a little semicolon, so the 2 dots, 10, not semicolon, that's just colon, right? What's a semicolon? Semicolon has a comma, right? 3 to 10. And 4 to 1.5. Now, some teachers in the past might have taught you with ratios, it's not okay to have decimals. In the ideal world, in the extremely perfect world, yeah, we don't want decimals. But in the real world, are we going to get decimals?
Yeah.
When we measure like a length of a table compared to the height of a chair? Yeah, we're going to get decimals, okay? So we have to kind of get used to using those, okay? So I need to see if these are equal. And this is kind of a goofy way of setting it up is with the colon sign. So instead of using the colon, what other way could I write this? A fraction, 3 over 10. And how would I write this one? What would go in the numerator? 4 over. Now these might not look the same, but we do need to check to see if they are the same. So one way we can do that is by doing the simplifying fractions, or we can convert them to decimals. And this is where using your Desmos calculator is going to be really nice, because you can plug them in and check them just without even having to memorize anything. So 3 over 10 is 0.3. And I'm going to hit this enter sign at the bottom. Normally it's blue, but I reversed my contrast so you could see it better. And then 4 divided by 1.5. And that way I can compare them top and bottom. For the sake of notes, I'm going to write that in as 2.6 repeating. If I wasn't doing any notes, I could just answer the question. Is that are they equal? No. And we could have known that right away within that fraction. What do you notice about our relationship in the first fraction compared to the second fraction that would tell us that they can't be the same? Not necessarily a decimal. Decimal could have been okay. Yeah, in the first one, the top number, the numerator, is smaller than the denominator. So we're going to get a number smaller than 1. In the second one, the numerator is bigger than the denominator. So we're going to get a number bigger than 1. So we know if we get a smaller less than 1 and smaller less than 1. A number less than 1 and a number bigger than 1, they're not going to be the same. All right, let's do one more. If I have 6/8 and 33/44. How could I check to see if these two make a proportion or are proportional to each other? What? Calculator. What's another way we could do it? Yeah, we could simplify those fractions. So we could divide top and bottom by a common number. What would I divide 6 by? 6 and 8.
We could simplify. What can we divide both of those by?
2. What's 6 divided by 2? 3. Divide. 8 divided by 2. 4. What can I divide both 33 and 44 by? 11. And what's 33 divided by 11? It's just if you know your factors. But if you don't know your factors, good news, you can just use a calculator. Okay, so it's up to you on how you want to decide. If you're somebody who you like to simplify those fractions, it's something you practice a lot in pre-algebra, you're like, dang, I'm amazing, do it. If not, you can always just type in 6 divided by 8. I'm going to hit that enter button so I can still see that. 33 divided by 44. And we get 0.75. If you need a factor sheet, if that's something that you want to do, you want to keep those fractions and you need to see a common factor, we do have factor sheets that you can borrow. So in this case, is this a proportion? Yes. Why? Because they're the same. If you want to put a not equals there, you could. Or you don't have to. It's up to you. All right, number 2, this is our wordy problem. I think someone's there. I don't know. To the restroom? What? Yeah. I wasn't listening to anything you said. Yeah, totally. Next time you don't have to ask. Just do it. All right, number 2. This is our wordy problem of the day. In triangle EFG, the ratio of the measures of the angles is 5 to 12 to 13. My question is going to be, what are the measures of the angles? The ratio of the measures of the angles, is 5 to 12 to 13. And we want to know what are the measures of the angles. So if you think back to the stars and the circles, we know that when I multiply one part of a ratio, when I did the stars 5 times, 3 times 5 was 15, what did I have to do with the other part of the ratio? Yeah, we did 5 times 5. We multiplied both parts by 5. In this problem, we don't know what we're going to multiply 5, 12, and 13 by. So if we don't know what we're going to multiply by, what are we going to use in math? What stands for an I don't know? I think someone mumbled it.
What can we use in the place of something we want to find out? Or something we're not sure about? A letter, a variable, yep.
Good. But one thing that we do know about a triangle, what do we know about all the angles in a triangle? What? They equal 180. Good. Sorry, it's a little loud in the hallway, so it's hard to hear. Okay, but we know that when I take 5, 12, and 13, does 5 plus 12 plus 13 equal 180? No. So we're going to have to multiply these all by the same number. We just don't know what number yet. So we're going to say 5x, 12x, 13x. And then I want to solve that equation to find out what is that number we're going to multiply all those angles by. So what is 5 plus 12 plus 13? I see a couple people have their phones out already, which is great. So you can just go to that calculator. And just go to your calculator. 5 plus 12 plus 13.
You want to know how my crazy brain does it? I do 12 plus 12 is 24, and then I add one more, then 25, and then I add 5 to that, that's 30.
You're nuts.
I know.
I would do 2 plus 3 is 5, and then 5 and 5 is 10, plus another 10 plus another 10 is 30. Alright, 30. X equals 180. How are we going to solve that? Yeah, because when that 30 and x are right next to each other, that means what? Multiply. And how do we undo multiply? Divide. We're going to actually talk about that in a little bit, but backwards. So x equals, what's 180 divided by 30? Like 6, right? All right, did that answer our question?
Does it say solve for x? No. What does it tell us to do? Oh, so do we know the measure of the angles yet? No. So we're not done.
So we know as we have 5, 12, and 13, and we're going to multiply all of those by the same number. What am I going to multiply each of those by? 6. So 5 times 6. 12 times 6, and 13 times 6. So what is 5 times 6? 30. So one angle is 30 degrees. 12 times 6, 72. And 13 times 6. And if we add those angles together, what should it equal? Yeah, hopefully 180, 30 plus 72 plus 78 equals 180. So we got it. All right, we have two more problems. These ones are going to take us back to some pre-algebra. Okay, or algebra 1.1, or intermediate algebra, whatever you called it. The algebra prior to geometry. Those of you that maybe didn't have algebra for some whatever reason, this might be new to you, so make sure you're asking questions during practice time or during this time if you really need it. If you have any questions about this at all. So our directions are going to be to solve the proportion. I'm just going to write solve. When we see that word or that direction solve, what do we want our answer to look like? Yeah, like x equals a number, right? Or m equals 3. Okay, so here's example number 3. I'm going to have 5 over 4 equals m over 3. So I want this to be a proportion. I want two fractions that are going to be equal to each other. So I need to figure out what number can I put over 3 to make those two fractions equal. And that doesn't really quite compute in our heads, because how can we make a 4 into a 3? And whatever we're doing there, we'd have to do the 5. So we're going to just solve this equation like we've been practicing. What's another way to say this line? Or what does that line mean in operations? Divide. That's a division sign. So if I want to get m by itself, how would I undo division? What is the opposite or the inverse of divide? Multiply. So I'm going to multiply by 3. If I do that on one side, do it on the other side. When I multiply by 3 over here, it can be a little goofy, but because we have that division and that multiplication, those undo each other, and I'm left with just m. On the left side, this is again where having your Desmos calculator might really help you out. Okay, 5 over 4. And then when you multiply, you're going to want to put it off to the side, times 3. And we get 3.75, or 3 and 75 hundredths. So we do get a decimal, and that's okay. So in my calculator, we did 5 over 4 times 3. 5 over 4 times 3. That might be new to some of you. All right, last problem of the day that we're going to do together, number 4. Okay, with number 4, we have 6 over 9 equals 7 over 3n minus 5. So what's different about this problem compared to the last problem? You got it. What's on the bottom this time? The n, the variable. So the variable's on the bottom. What else is different? Yeah, there's a 3n minus I. It's not just n. Okay, so first thing that we're going to want to do is we want to flip it to the numerator, or flip it over. I always want that variable on the top. So my next fraction, all I'm going to do is put 3n minus 5 over what? 7. But if I flip one side of my equation, what do I have to do to the other? The same thing. So what's my other side going to be? 9 over 6. And that only happens if my variable is on the bottom. I just flip it over so it's on the top. Now, who's hanging out with the n? Which numbers are like buddy-buddy with the n? The 5 and the 3. Whoops, sorry. Did I negate what you said? These guys are hanging out. It's like they're like hanging out upstairs. 7's hanging out by itself downstairs. So it's by itself. So this is like a grouping symbol, parentheses. We want to keep that together as long as we can. So we're going to undo that dividing by 7 first. And how would we undo dividing by 7? Multiply. And if we do it to one side, do it to the other side. Good. And I don't know what that is out of my top of my head, so I'm going to use my handy dandy calculator. 9 divided by 6 times 7 is 10.5, or 10 and 5/10. And then a lot of you, we've seen the last couple weeks, you're really, really great at solving these two-step equations. At this point, if you wanted to solve that on your own or work ahead, you can. If I want to get n by itself, now it's the 3 and the 5, that's all that's left. So am I going to undo the 3 first or the 5? Got the 5, because multiplying is more important than subtracting. So how do I undo a minus 5? Good, add 5. And if I do it to one side, do it to the other. We get 15 and 5/10 equals 3n. And then our last step would be to do what? Divide by 3. And again, I don't know what that is. I'm going to use my handy dandy calculator. And we get 5.16666666666. How do I write that on my notes? Just 5.16? How do I show the repeating? Good. The line. Does the line go over the 1 and the 6 or just the 6? Just the 6. Good. If I wanted to round it, it'd be 5.16 or 5.17. Does that 6 go up to a 7 or does it stay a 6? Yep, it goes up to a 7. Good. That 6 tells us to round up. Okay, in your practice today, though, it will be a terminating decimal, meaning it'll end. That way you don't have to worry about rounding or you don't have to worry about that repeating sign.